When we try to solve the tangent problem, right? This limit is very important. What's that limit? The limit is what's the limit of as x goes to a here, f of x minus f of a over x minus a, right? That's a very nice limit which captures the slope of the tangent line at the point A, right? It has many applications in the velocity problem or any other rate of change problem. We can apply this limit. So this is such an important limit. So we give a special name for the special limit. We call that the derivative, right? This is our definition here. Definition is basically motivated by tons of applications. We give a special name for this limit, the difference of y value of a function over the difference of x value. So any problem related to rate of change, you can apply this limit, right? So we call that the derivative of f at a, right? We don't want to write this all the times, right? So we give us a notation for that, which is f prime of a here, right? Is what? Is the following limit. Sometimes the limit doesn't exist, right? For sure, there's some function, the limit doesn't exist. So if the limit exists as a finite number. So as long as this special limit has a limit exists, right, as a finite number, we call that number to be the derivative of our given function at the point A here, right? And note we can rewrite our there's another equivalent definition, right? So we can do a substitution here, just small note or remark, if you call that. We let x minus a here equal to h, right? In this case, we know that because it's difference x minus h, x minus a, sometimes it's not easy to like just cancel that. Just we want to make it easier, right? So we just give a name for that. We call that h. If you do this substitution, then x equal to a plus h, right? Quite easy substitution, right? And as x is getting closer and closer to h, a here, then h will getting closer and closer to 0, right? Because that's their difference. So x is getting closer and closer to a if and only if h goes to 0, right? So now we can rewrite our limit in a new form. So as x goes to a here, f of x minus f of a, do the substitution here by h. So this is same as h goes to 0, f of a plus h minus f of a over h, right? So follow from our substitution, we get this new form, right? New form of definition, right? This is also our f prime of a, right? Also the derivative of this function at a normal difference. So that's just a new way to write down the derivative, right? Define the derivative. So let's see another example, right? Try to figure out what is the derivative of a function, right? Let's say example, it might mean difference in slopes or rate of changes or velocities, right? Depends on the problem, right? What's the meaning of this function? F of x equal to 2x plus 1 over x plus 2. We want to find what? Find f prime of 1, right? So that's what we want to do. How do we do that? We want to use our definition here, right? So far, we have only definition to use. F prime of 1 here equal to, we can use either the definition 1 here or the second form, right? Form 1 or form 2, not much difference. Let's try to use form 1, right? So this is as x goes to 1 here, f of x, which is, okay, f of x minus f of 1 over x minus 1, right? So that's basically what happens. And so this is as plug in the function, x goes to 1 here, f of x is 2x plus 1 over x plus 2, then minus f of 1 is 3 over 3, which is 1, right? 1, you get x minus 1, right? Now, again here, right, this is 0 over 0 kind of limit. This is undetermined. So we want to cancel the zero factor in the denominator, right? So how do we solve such a, evaluate such a limit? We want to, we need to cancel x minus 1, right? In the denominator. And because that's a term, that's a factor which that's a term, that's the reason we cannot plug in 1, right? If you plug in 1, you get 0 in the denominator, right? So how do we do this? So this is, we don't just use algebra, right? You want to factor x minus 1 on the numerator out, you will start from taking the common factor, right? So this is 2x plus 1 minus x plus 2, right? And so this is equal to as x goes to 1 here, if you try to simplify the numerator of the numerator and also try to regroup the fractions, you get x plus 2 in the denominator times x minus 1, then times x minus 1, because 2x plus 1, then minus x, and minus 2, you get x minus 1. So this zero factor cancel each other. And so the answer is, then you plug in 1, the answer is 1/3, right? So this is the example. Given a function, given a number, you can calculate the derivative of this function at this number, right? So that means the slope, right? If you are looking for the tangent line and to the curve at this point.